All right, so today still looking at combinations. At this time we've got some restrictions occurring on it. All right, so we'll look at some different restrictions. So the first restriction is you might, for example, want to include a specific item. So here's an example where that might be the case. So the group of 10 students, if Freddie must be in the team, how many teams of 4 could be selected? All right, so teams of 4, and we've got Freddie in. So if we've got Freddie in, well, we've now got nine other students. And if the team is a team of 4, but Freddie's already in it, we need 3 others for the team. So what we've then got in this particular case is we've got we've got this here, haven't we? We've got 9 students and we're selecting 3 others. And again, order's not important because it doesn't matter. If John's in the team, John's in the team. Doesn't matter whether we select him next or we select him last. Doesn't matter if he's in the team, he's in the team. So order's not important. So what we're actually doing is we're choosing 3 others from the 9 that are left. So we go on 9C3. And then when you do that on your calculator, because I've prepared one earlier, you get 84. So there's 84 different teams that could be selected. All right, so that's if something has to be included, but then there might be something where you can't have a particular thing. So you want to exclude something. So for example, 4 students to be chosen for the tennis team from a group of 8. Well, you know, you would think, okay, 8 choose 4. But you get a problem. Liam and Noel, they do not like each other and cannot both be on the team. How many ways can the team be selected? All right, so what do we do? What sort of strategy can we use from this? All right, so what we could do is we could look at no restriction. And that'd give us the total possibilities altogether. And what we can then do is minus minus both in the team. Okay, because it'd be tricky otherwise, because you could have one of them in the team, or the other one, or none of them in the team, so that's a whole bunch of stuff. So we're trying to think of ways that we can make this more simple. So if we look at everything, and then of course some of those with everything have them both, but we don't want those ones, so if we take them out. So no restriction would be then is we've got 8C4. Again, it doesn't matter how many we choose. And if they're both in the team, all right, so they're 2 people and they're both in the team. So if we had our 8 and we're taking those 2 out, we've now got 6 to choose from. Now, if they're both in the team, and there's 4 people in the team, we've already got those 2 in there. So we're choosing another 2. All right, so of the 6 left, we need 2 more to make up the team. All right, so on your calculator, go 8C4, which is 70. 6C2 is 15. So there's 70 teams possible. 15 of those teams have both Liam and Noel in it. So there's 55 ways that we can select the team which doesn't have those 2 in it. So we don't want to cause any problems. Maybe they don't like each other enough that they're going to punch each other up or something. Who knows? All right. So there's that strategy there. So if something's excluded, include it and take it off the rest. All right, multiple groups. So say we have different groups of things. So like here we've got a club of 20 female and 10 male members, how many committees of 4 can be chosen? All right, so we've got males and females. So do we have restrictions on numbers of each, or do we not, or whatever? So you need to read the question and have a look at the question. So with this, it says without restriction, so it doesn't matter. All right, it doesn't matter. Combination 2 females, 2 males. Could have 2 of each, containing at least 1 female. All right, so let's have a look at some solutions. So if there's no restriction for A, no restriction, we've got 30 people in, and we're choosing 4 for that committee. All right, and so there's 27,405 different ones, because I've prepared one earlier. No restriction. However, in B, there is restriction. There is. We've got to have 2 males, 2 females, and 2 males. So B, we want 2 females and 2 males. And I've highlighted that word "and" by making it bold, because the word "and," when it comes to this sort of stuff, and for probability, indicates multiplication. All right. So when we go down the next line here, we're going to multiply those 2 things together. Oh, rubs all of that out. That's not what I wanted to do. So, and. So we're going to multiply. So 2 females. Well, we had 20. Yep, 20 females. So we want 20 females. We want 2. And there's 10 males, and we want 2. So 20C2 times 10C2. 20C2 is 190 times 45, which is 10C2. And so there's 8,550 different committees that could be formed where it has 2 females and 2 males in it. All right. This next one, part C, containing at least 1 female. So there's a couple of different approaches that we can do. So we want at least 1 female. So that's R is greater than or equal to 1. So there's 2 approaches. First approach, we can do 1 female, or 2 females, or there could be 3 females, or there could be 4 females. All right, and you see I've emphasised the word "or" and the word "or" when it's used in this context, and probability indicates addition. All right, so there's a few things to do there if we were to do that particular method. The second method would be to say no restriction minus no females. All right, which would be the same thing, because it's a committee of 4, the only other option to all those ones that we've got there is no females. So there's 2 ways of approaching it. You choose which one. I'm going to choose the second one here. All right, so the second approach, no restriction. Well, there's 30 people and we're choosing 4. Minus no females. All right, so we've got 20 females and we're choosing none, times by 10 males and we're choosing 4. All right, because what do we want? We want no females and 4 males to make up our committee. All right, so 30 choosing 4, we did that earlier. Squeeze it down in the bottom here, and that was 27405 minus 20C0, there's only one way of doing that, and 10C4, there's 210. And so when you work that out, you get 27,195 different committees that you could choose if there was one or at least one female in that committee. All right, sometimes you may need to combine permutations and combinations. So let's have a look and see. A president, vice president, secretary and treasurer is chosen from a group. So now you see here, this time we've got specific roles, whereas the previous question we didn't have roles, we just said people on a committee. But this time we've got specific roles. So John might be the president. Now that's a different committee than if John's the treasurer. All right, because they have specific roles. So in that case, the previous case, the arrangement was unimportant, but in this case, the arrangement is important because of the roles thing. So there's a bit of a combination then of permutations and combinations from the group. All right, so we get 7 women, 6 men. How many ways can this be done if exactly 2 women are chosen? All right, so we've got 2 women and 2 male men. Whoa. Let's go. 2 women and 2 men and 4 roles. Now this first, the women and men, we just got 2. Now it doesn't say here when we're saying 2 women are chosen, it doesn't say that those women have to have specific roles. So they could have any role. So what role they have is, in this case, not important. It becomes important later when they take up those roles, but it just says that they're on the 2 on the committee. Any 2 of those roles is filled by people. So unimportant about order for that. So we've got 7 women, we're selecting 2, and times we've got 6 men and we're selecting 2, and we've got 4 roles. All right, and so 4 roles for these 4 people to fit, 4p4. Of course, it's just 4 factorial for those that have remembered that. All right, so the way we've approached it is we've said, all right, well, it's not important what roles they have at the start here, not important what roles they have, we want 2 women, we want 2 men, not important what roles they have, and then we go, oh, hang on a second, we've got 4 different roles, so if John's the president or John's the treasurer, that's 2 different roles, 2 different committees, of what they actually do on the committee. All right, so that's where this last bit here comes into it. And so, of course, you get your calculator out and you do all of that on your calculator, and you can set it all up as 1 and get it all to multiply it all together. Let me do that. All right, since this is the last example, so here we go. So we got 7C2, 7, 2. Don't forget close your brackets times 6C2, close brackets times 4 factorial. And go, there we are, 7,560. So there is, of all of those people, 7,560 different possible committees that you could have. All right, so the approach that you're going to take to these depends on the restrictions. So read carefully about the restrictions and what's going on. Look for those key words, arrangements, selections, and or those sorts of things to help you along the way. All right, so reading carefully the question and picking up those things is important. And as always, have fun.